So we're going to study about chemical reactions and equations. Now before we go into chemical reactions, we have all known this term which is called change. Now we know that this change can be of two types, either physical or chemical. A physical change means there is no as such change of state or change of color or something taking place. It means that it's just a physical change, like the breaking of a pencil, or just you can say solid changing of water into ice. So that it does not involve any chemical reaction as such. But in chemical change, it always involves a chemical reaction. And chemical change can be like, suppose you burn a matchstick. So what happens? You burn the matchstick and the matchstick changes into its residue. So can you get back the matchstick from the residue? No. So we can say that a permanent chemical change has taken place. So, burning of paper, burning of a matchstick, or you can say food getting cooked, all these are chemical changes because there is some chemical reaction involved in these changes. And you cannot get back the product, you cannot get back what you have used as the reactant. So, basically, we will study about chemical changes, or we'll more specifically study about chemical reactions. Now, there are some very basic things to identify whether a chemical reaction has even taken place or not. So, you can get a question that how can you say that a chemical reaction has taken place? So you can say that the chemical reaction has taken place due to, first of all, a change of state. Like you're putting salt into water. The salt, which was solid, has now turned into aqueous. So that's a change of state. Or you can say when you do electrolysis of water, the H2O, which is water, it changes into hydrogen and oxygen. So this water, which was liquid, changes into hydrogen and oxygen, which are gases. So you can say that the chemical reaction has taken place due to the change of state. Now, a second point could be a change in color. You'll see, if you take a magnesium ribbon, you'll see that it is silvery white in color. It has some silver sort of color, and if you burn it, then you will get a blackish or grayish sort of a substance. This thing is your magnesium oxide. Because what happens is that this magnesium ribbon, when you burn it, suppose you have a candle and you burn this magnesium ribbon, then due to this burning, it takes place in the presence of oxygen. And this magnesium reacts with this oxygen, and the residue which you get is nothing but magnesium oxide. So this is a reaction between magnesium and oxygen to get magnesium oxide. So they might ask you this question: what happens when you burn a magnesium wire? So you have to say that due to the burning, it reacts with oxygen and forms magnesium oxide, and the silver color of the magnesium changes to the blackish grey color of magnesium oxide. There is one more question regarding this magnesium wire. It's that why should it be cleaned before the reaction? Why should the magnesium wire be cleaned before the reaction? You know, you have to clean it with sandpaper to remove a top covering. So the answer to this is that magnesium, when you are keeping it in the open, it reacts with the oxygen present in the air and it forms a magnesium oxide coating. And this coating covers the magnesium wire. So if you take this wire and burn it, you'll see that the flame will reach only till the coating. It will not reach till the magnesium wire. So the coating of magnesium oxide does not react with oxygen. Only magnesium reacts with oxygen. But in this case, the magnesium wire is not reaching the flame. That is why you need to rub this wire or clean this wire to remove this coating of magnesium oxide, so that the magnesium can freely react with oxygen. So it's a very common question. Why should it be cleaned before the reaction takes place? Now the next thing to determine whether a reaction has taken place is change in temperature. Now change in temperature means, you know, the reactant has some temperature and the product, you either is colder than the reactant, or it's, you need heat for the reaction to take place, or the reaction evolves heat. Like if you take some glucose, or rather if you take some ammonium chloride, it's NH4Cl, the formula for ammonium chloride, and if you mix this with water, you will see that the beaker becomes cold. That is because this ammonium chloride, when mixed with water, it needs heat to react with the water. Ammonium chloride reaction with water is just the dissociation of ammonium chloride into its ions, NH4 plus and Cl minus. But to form these ions, it needs some energy. And from where it takes the energy? It takes the energy from the walls of the beaker. That is why the walls of the beaker, when you touch them, they go cold.